Okay, so let's get rolling. For starters, my alarm is going to go off here at 11:10. When I get confused as to why it's doing that, I need to be wrapping up class because I need to get to a meeting in Mequon by 11:30. So I'm sure I'll be confused and not know what time it is. So that's going off and I seem flustered. That's the scoop. Somebody tell me to give you the homework and shut up, or maybe we won't have homework. We'll see. All right. So how did the Java homework go? Too easy?
A bit difficult.
Bit difficult.
I think I was able to reuse some of the assets to create my favorite.
So, all right, let's take a look at it. Oh, you want to see something cool? This is a hydrogen atom underneath a quantum microscope. Isn't that kind of cool? You're seeing the actual, this is the electron orbiting the proton. We're modeling that on a quantum computer. That's kind of a cool thing. Kind of like peeking into God's world. All right, let's see. Is this us? All right, so I gave you a starting point. We're supposed to implement room and exit. Build your own dungeon with 5 rooms. Each room should have at least 1 exit, blah, 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 blah. Details, stuff. Okay. And I think we did some, oh yeah, so we kind of describe what a room might be. We describe what an exit might be. Okay, so let's go and write this. So based on some of the questions I did get, let me... There seems to be some confusion as to the when you should be creating new files versus not. This is not a Java versus C++ thing. So, for example, I had a question this morning saying, I've run out of space on the top here where I've created too many files and it's wrapped around and stuff like that. If you're creating that many files, you're either working on a much larger project than this. So for this homework, you only needed to create 2 new files. You had to create room and you had to create exit. All right. And then because every time we create a class, that is the basis for creating instances of that class. So we would invent this idea, invent the blueprint for a room. That would be our room class. And then we would create for this assignment, what I say, at least 5 rooms. You would create 5 instances of room. And then you would create however many exits you need to connect those rooms together. So let's start off and we'll just look at this through examples, right? But the important piece there is I want you to understand that this does not deviate from the knowledge from C++. It's exact same mentality, which is why I wanted to pivot to hopefully drive that point home that all these languages are basically the same. Okay, so let's start. We're going to create room.java. All right. Let me hide that guy for now. That's big enough text. See that? All right. And what did I say a room was going to be? A name, a description, an array of exits, and a display method. Okay. So we're going to have class room. Then we're going to have our fields for our room. So here's our fields. So we're going to have a name, which is probably going to be a string, a description, which is probably going to be a string, an array of exits. We haven't even invented exits yet, but we will. We'll have a collection of those guys, the things we're going to invent, and then this display method. So let's just start off with our first 2 fields, name and description. We'll throw our exits in there after we invent exits, okay? So we're going to have a private string, and in Java, it's a capital S, and this is going to be the name of the room. We'll have a private string description. All right, then we're going to need a constructor. So I'll put a little comment in here. Ooh. We're going to build a constructor for this guy. Remember, all classes are made up of collections of three things: fields, constructors, and methods. All right. You don't have to put these comments in there for fields and constructors. I'm just trying to drive that point home. So our constructor, very, very, very likely most of the constructors you ever write will be public. Anybody give me an example of when we might make a constructor private? Remember the difference between public, private, protected. Public means it's accessible anywhere. Private means it's only accessible inside this class. Protected means it's accessible inside this class as well as children of this class. We talked a little bit about that last time. Anybody have an example of when you might make a constructor private? So let's assume, I think we saw last time that you can actually create multiple constructors. And then I also had an example where we have a child class call its parents class method. We introduced the super keyword. So we could have a public constructor that takes in two parameters. And maybe that public constructor then internally calls one of its private constructors that does some extra startup stuff and takes in some extra parameters, maybe based on the current time of day or something like that. And now that might be a constructor we don't want externally to be used by people, right? We want people to use the public constructor that maybe passes in a name and a description. But then internally, we have a private constructor that we pass those two things to, plus maybe a couple of other pieces of information that we internally figure out in top secret, in a top secret way or whatever. So it's not a publicly available constructor, but it is a constructor that we intend to use privately inside the class. Probably not a super common occurrence, but I wanted to throw that out there just from the perspective of, I don't want you to necessarily just start off with the assumption that constructors always, always, always are public. They're almost always, always, always public. In practice, they're probably almost nearly always public. Constructor has to have the same name as the class. We're going to take in a name and a description, and we'll set this guy's name equal to name, this guy's description equal to description. And that's what the constructor for our room does. All right. And then we'll go ahead and give ourselves a display method here. Here's our methods for our class. And by the way, Java doesn't care what order you put this stuff in. If you want to put your fields at the very bottom, you can do that. Probably not normal convention. This would be normal convention. Your fields come first, then your constructors, and then your methods. So we're going to have a public method here that's not going to return anything. So it's going to be void. It's going to be called display. Okay, remember in Java, we include the implementation and the definition inside the same file. We don't have that header file and the implementation file like we did in C++. Even though I kind of make the argument that I think the C++ model is actually superior based on the actual behavior of programmers in Java. The initial idea of Java was everybody's going to use this magical Java doc tool that they can take their program that they write all verbose like this and generate a web page with that self-documenting. But nobody does that. So really you're stuck with all of your definitions plus your implementation all inside of one file. But I did show you last time we have like that little ability to minimize your stuff so you can sort of kind of turn it into a header file at a glance, that type of thing. All right, so this guy's going to be public because we want to be able to call that display method from outside of our well, let me make sure I'm recording. I'm pretty sure I am, but yeah. We want to be able to call that display method from outside of the room class, presumably inside of our, what do we call it, driver class in this case. And let's just go ahead and print out that we're a room that has a name, whatever the name is, and has a description, whatever the description is. So we'll do something like system.out.println. room, maybe put an opening parenthesis there. Then we'll add to that this dot name. We'll add to that maybe a closing parenthesis. Let's do an arrow and then a smiley face. And we'll just do a space there and we'll add to that this dot description. I should have just kept going down the line, smiley faces, underscores until somebody thought I was going crazy. Wow, that's probably most of you have assumed that ship has sailed. All right. So that's what display is going to do right now. We just decided if I create a room and tell the room to display itself, it's going to say room, whatever we name the room and whatever the description is. Okay. So let's stop there for our room for the moment. And now let's show how we can use that. So this would maybe be the first step of how you should have gone about your homework. Utilizing what we learned last class where we created this player and monster, and inside of driver, we created instances of those guys. So I'm going to go ahead and gut that. And we're going to go ahead and create room. R1 is a new room. All right. And we're going to, for our assignment here, we're going to have 5 rooms, right? All right. So we'll create them in a second. So here we're going to very imaginatively name this room 1. All right. And this will be a description of room 1. Just amazing stuff that we're doing here. All right. We really thought through this to describe the inner workings of the room. Create 4 more of those. You could done more than 5 rooms if you wanted. All right, so I have so keep in mind here, I invented what a room is. That's what this guy is. Okay, this is my blueprint for building rooms. Out here is where I've actually used that blueprint to construct 5 instances of room. Make sense? Okay. This is how you make multiple rooms. You don't create a new file for every single room. All right, is that clear? And again, this is not a Java thing. This is something that same thing in C++ that we saw in C++. All right, and then we'll go ahead and test our display methods. So we'll tell R1 to display itself. Tell R2 to display itself. All right, so we'll go ahead and run this and we'll see our 5 rooms display themselves. Oh, I had left a. Let me just get rid of that for the moment. That was a bug left over from previous thing. All right, so there's our rooms. All right, so far so good. All right, so room is almost done, except we haven't actually created our connecting pieces yet. So now let's go and before we write exit, let's go draw some pictures because we want to design our dungeon here. All right, so I'm going to that's going to be R1. R2, 3, 4, and 5. All right. And now we want to organize these and what our dungeon's going to look like. So maybe R1's our dungeon entrance, and it flows into maybe R2, and then we have R3 with R4 to the left and R5 to the right, something like that. All right, here, we'll do this. We'll throw a little Christian worldview in here. We'll create an R6 and finish the cross. Ba-bam. Our teacher told us the cross is a dungeon. All right. All right, we did 6 rooms. I didn't update these guys, did I? 3, 4, 5, 6. All right. So there's our 6 rooms. And we're going to decide our dungeon's going to look like this. All right. So we've decided that's what our layout's going to be. So now we need to connect these guys to each other. And we decided that we're going to connect rooms using things called exits. All right, so let's do some pictures here. Is this an exit? Maybe that's an E1. You probably want to maybe shrink that down a little bit. Maybe turn it yellow. Call that good enough. All right, so maybe E1 connects room R1 and R2. But keep in mind, I think last time we talked about, do you want to have a single exit that goes both ways, or do you want to have E1 goes from R1 to R2 and E2 goes from R2 to R1? So maybe for every little pathway, we have a different, let me shrink down the size of this text a little bit so we can shrink down our connections. All right, so that's E1, E2, E3. Here's some more. Here's some more. We'll see if that's enough. All right, so here we have E1 and E2. Connecting those guys together. Actually, I'm gonna just copy again. I like this better. Those guys connect those guys together. Those guys connect those guys together. Our worlds are colliding. All that good enough? All right. So we'll say this is E3, E4, E5, E6, E7, E8, E9. Ooh, it's gonna get too big here. All right. So we're gonna need 10 exits to model our thing here. So what's an exit? We decide an exit is going to have a direction that it leads and then the room that it leads to. So E1 maybe it heads to the north to room 2. Make sense? E2 heads to the south to room 1. E1 would be contained within R1. So R1 holds an exit called E1, holds a collection of exits, but in this case, the collection is exactly one exit. E1 heading to the north, whose destination is R2. Make some sense? All right, so let's go and invent exit now that we've done our Lego version of it. All right. We'll add a file, exit.java. We'll have our class exit. All right. And an exit's going to have a direction. So here I'll put our fields in here. We'll have a string direction. And then we're going to have our room destination. We'll call it destination room. All right. So that is, what direction does this exit lead to and where does it go? All right. Constructor. We're going to have, and these guys will both be private. Constructor has to match the name of the class. So in this case, that's exit. We're going to take in a string direction and we're going to take in a room, destination room. We'll set this direction is equal to direction. This dot destination is equal to destination room. All right. So just start off with that. So that's what an exit is initially. Okay. Now, let's go back to our picture. For example, if R1 is going to, if we pretend like we're standing inside of R1 right now. R1 is going to have a collection of exits. In this case, it has exactly one exit because we decided this exit belongs to this guy where E2 belongs to R2. So R2 actually has a collection of two exits, E2 and E3. One heading to the south, one heading to the north. All right. So we need to now teach our rooms to how to have a collection of exits, an array of exits. Do this the same way as we do in C++. So we're going to add to our fields for room. We're going to have a private exit array. Call this guy the exits. All right. And then initially what we're going to do is we're going to give our exit array an initial size. We're going to decide, since we're dealing with the cardinal directions here, north, south, east, west, we just decide that's our limitation. That means the most number of exits a room can have is 4. Okay. So we'll go ahead and say this dot the exits is equal to a new exit array, size 4. In, let's call it real programming, where we have more tools in our toolbox. Perhaps we would choose not to use an array for exits. Maybe we would use a linked list, or kind of the halvesy step in Java is something called an array list. But an array works good enough for us, and we know what arrays are. So we're just going to give ourselves a container capable of holding 4 exits, but we might not put all 4 exits in there, right? So that container might actually sit somewhat empty. So we'll swing back to that here in a second, because if I have a container to hold 4 things and I need to know, and we're adding an exit to the room, I need to know where to put that next exit. We're probably going to have to keep track of how many exits we currently actually have stored. All right. So a room can hold exits. So when we first constructed a room, we said, okay, we're going to go ahead and create a bucket capable of holding 4 exits. But this particular instance of room, we do not know what exits, if any, are going to end up in this room. Hopefully you wouldn't have a room with no exits, but I guess if we add teleportation to our dungeon, possibly you could end up in a room that doesn't have an escape. I think back when I first wrote something like this, I want to say maybe I was 11 or something like that when I used to play Dungeons and Dragons and decided to do this kind of crap. I think, I don't know, in my 11-year-old messed up boy mind, I guess I had like this wood chipper that would travel around our dungeon, and sometimes it would become the room you're in and the exits would keep changing and you would take all sorts of damage as long as you were in the wood chipper room. Yeah, we should have known back then that there were problems, I guess. So I mean, you got to start with, why did I call it the wood chipper room? That's already concerning. So all right. So what was I talking about? Oh yeah, wood chippers. So all right, so we need to have the ability to add an exit. So we're going to have public void add exit. And this guy will take in an exit E. All right, so when we add, oh, and I'll go ahead and put that under my methods section just for completeness, which means just put it underneath the comment that says methods. All right, so I want to add this exit somewhere. So I'm going to say this dot the exits at bucket, I'll put a little question mark here right now, is going to be equal to E. All right, so whatever exit we're passing in, we want to add it to this room's collection of exits. Presuming we've constructed this exit outside of here. So we've already given the exit a direction. We've already given the exit a destination room. So now we're just saying, okay, in our example here, room 1, I want you to add this exit to yourself, in this case, E1, which heads to the north to room 2. All right, but we've already built that into E1. So now we're just adding it to R1. But what bucket of our exit array do we put that in? Well, we have 4 total buckets. Do we put it in bucket 0, 1, 2, or 3? Well, we're going to have to keep track of how many exits we currently have in there. Don't confuse this with I mentioned last time that Java's arrays have the ability to report how many elements they're capable of holding. C++, we always had to pass around the size of our arrays, right? Because an array was not smart enough to advertise its maximum capacity. In Java, the length of an array is its maximum capacity, but it doesn't tell us anything about how many things we've already put in there, right? The exits.length will always give us a 4, as we have it written right now. No matter how many exits we put in there, if we put 0, 1, 2, 3, or 4 exits into it, its length will always be 4. So we need to then internally keep track of how many exits have we already stored so we know where to put the next one. We're probably going to store the very first exit we add in bucket 0, the next one in bucket 1, the next one in bucket 2, and bucket 3. So internally here, we'll create a private int num exits. And we'll initialize that to 0. We currently, when a room is first born, it has 0 exits in it. Okay. Now you could have actually initialized it up here. You could just say, oh, we'll just start it off at 0 and then not put that in my constructor. Let's just say it doesn't really matter. The reason I'm putting it in the constructor is to drive this point home of what's the job of a constructor. It's to initially construct an object, initialize an object. And what it means for a room to be fresh out of the oven is it has a name, it has a description, it has it has the ability to hold 4 exits, and it currently has 0 of them. Make sense? That's what a fresh baked room looks like. The constructor's job is to put it into that initial state. All right, so then to add an exit, we can replace this question mark with the location where we should put the next exit, which is this dot num exits, which started off as 0. So the very first exit we add, we'll put it bucket 0. Then we'll say this dot num exits plus plus. Oh, and by the way, not that I would recommend it in this case, this would be one of those situations where you could actually take advantage of your knowledge of whether the plus plus comes before or after the number. So you could have said this. The exits at bucket this dot num exits plus plus. Remember, when the plus plus comes afterwards, this guy will boil down to the current value of num exits, which is 0, and then increase it for future use. Make sense? As opposed to if I were to say plus plus num exits, now that 0 immediately becomes a 1, and then we get that value. So we try to put this at bucket 1. All right. Keeping in mind that when we first introduced this concept, I said you never actually have to remember. Well, it's probably good to have the academic knowledge of it, but in this case, I'm guaranteeing that this guy right here, his current value is 0, if it's the first exit we're adding. And then we're increasing it by 1. Doesn't matter if you say plus plus num exits here or num exits plus plus, it's going to ultimately leave it in the same state. Make some sense? So this would be an example where you can keep yourself out of trouble by not trying to show off by doing it all inside of one line. Not a major ordeal, but we'll hopefully avoid some errors in the future. But you will see folks who will try to save themselves one line of code by throwing the plus plus up there. So it's important to understand that concept. And this would be a perfect place where we could save a line, but who cares? All right, so when we added the first exit, we're going to put it at bucket 0, and then we'll update num exits to 1. So that if we were to add a second exit, we would put that at bucket 1 and then update num exits to 2. If we were to add a third exit, we would put that at bucket 2, then update num exits to 3, so on and so forth. Make sense? All right, so that's us adding exits to a room. All right, so now a room knows how to hold exits, and we know how to add exits to a room. So now we need to go back out and build all our exits to make it match up to this stuff. All right, so we need to make E1 head to the north to R2. So this is the more tedious part. So the constructor for exit takes in a direction and takes in where it's going. All right, so let me go back to driver. Let's go ahead and make a bunch of exits here. So we'll say exit E1 is equal to a new exit. And this guy is going to go to the north and end up in R2. That's what our picture says. E1 goes to the north to R2. And then we need a total of 10 of those guys, and then we'll update them. 3, 4, 5, 6, 7, 10. All right. So let's just go down our list here. E2 goes to the south and heads to R1. E2 goes to the south, ends at R1. E3 goes to the north to R3. E4 goes to the south to R2. E5 goes to the east to R5. E6 goes to the west to R3. E7 goes to the north to R6. E8 goes to the south to R3. E9 goes to the west to R4. And E10 goes to the east to R3. All right. We do need to make sure we put these in the right places because I want to say maybe I flip-flop my north and south somewhere in there. I'm not sure. It's okay on a per thing basis, but we just need to make sure we put the exits in the right place. So now we want to start adding our exits to our rooms. So let's go ahead and add E1, which should head to the north to R2 into R1. Here's E1 north to R2. So now we'll say R1 dot add exit. And the exit we're going to add is E1. All right. So we just added the exit leading to the north to room R2. We added that guy to our room R1. R2 gets an exit E2. R2 add exit E2. R2 also gets an exit. Let's see, do we have E3 going to the north or E4 going to the north? E3. So R2 also gets this E3. R3 gets E4 to the south. Yep. R3 gets E5 to the east. E5 is to the east. R5 gets E6 to the west. E6 is to the west. R6 gets E7 to the, to the south. I'm guessing I did it. Nope, other way around. So R3 gets E7 to the north. E7 north. And that is R3. All right. Then R6 gets E8 to the south. Just make sure E8 heads to the south. It does. Then R4 gets E9 to the east. Is that how I wrote it? E9. Nope. Other way around. So R3 gets E9 to the west. And R4 gets E10 to the east. Okay. So I think we have all of our rooms and our exits hooked up now. All right. So now just to test this, why don't we go ahead and let's update our display method to also show us the exits that are in a room. So not just the name of the room and not just the description, but also here's the obvious exits. All right. So let's go into room here and we're going to update display. We're going to say, show the obvious exits. Why won't you just let me click what I want to click? All right. So we need to loop through all of the possible exits that are in this particular room. Well, how many exits do we have in this particular room? What do you think? How many exits are in the room I'm currently in here? The answer to this question is an important concept that you all need to have now. I'll give you a hint. Generically, how many exits does this particular instance of room have?
Number of exits.
Exits. It has num exits, number of exits. Whatever that happens to be for this room. Make sense? We have to write the code generically because right now we are inside of the room class. We don't know which instance of room here we happen to be inside. We don't know which instance of room, well, how many exits that particular instance of room has had added to it. See, room 2 has multiple exits. Room 3 has multiple. Actually, room 3 has 4 exits, right? So some of our rooms have 1 exit, some of our rooms have more. When we are actually writing the code inside of the blueprint for a room, we have to talk about these things generically because we do not know which instance of room we're dealing with. So the room that we're currently in here has num exits, number of exits, and we want each of those exits to display themselves. So write a little for loop for it I is equal to 0, I is less than this dot num exits, I plus plus. Each time through, we want them to display themselves. And actually, I'm going to, just to make this look like a mud, I'm going to do a little line beforehand here. Obvious exits. And notice I said print, not println. So print displays on the screen, but does not press enter at the end. Because what I want to do is I want to say obvious exits and then like north and east or something like that right next to it instead of having the exits tall. All right. So obvious exits. I'm just going to write that word, put a space. And now for each exit that's in here, I want to be able to get the direction that exit heads. So that means I need to be able to, from within here, system.out.print, I need to be able to get the direction associated with each exit. So this is this dot the exits at bucket I, and I want to get that direction. But if we look at exit here, we see that direction is private, which means we can only access that inside of a class name exit. Currently, we are in a class name room. We cannot directly access it. We really want to say direction here, but we're not allowed to. And then I'm gonna tack on a little space so there's a space in between our things. So that means that we need to somehow give us access to the direction of this particular exit. And we do that with our getters and setters. So we're gonna, since we only need read-only access, we only want this exit to reveal to us the direction it heads. We just need to write a getter inside of exit called maybe get direction that returns the direction for that guy. So inside of exit, we'll add a method. This guy will be public. It's going to return a string call get direction, and this guy will return this dot direction. So this gives us read-only access to the private field that is only accessible inside of exit. And we have access to it here because this method lives inside of exit, where we do have access to its private fields. But what we've done now is we've given read-only access to this externally. Externally, they cannot change the direction, but they can get the string representation of that direction. Make some sense? All right. So instead of dot direction here, which will be an error, we're going to say get direction, which is the name of the method we just wrote. The public method that lives inside of the exit class. And it is an instance method. How do we know that this guy is an instance method when you look at it? At a glance, what tells you whether this guy is owned by the class or owned by an instance of the class? We're looking for a single keyword. Go ahead.
This.
Not this. Go ahead. Not public. Go down our list of keywords. We looked at this in the Java documentation when we were comparing the string class to the character class. I think we looked at the two uppercase method. Remember the two uppercase method inside of the string class looked kind of like this guy, where the two uppercase method inside of the character class had the keyword what in front of it? Static. Had the keyword static in front of it. So static methods are owned by the class itself and are therefore accessed using the class name. Non-static methods or instance methods that are owned by individual instances of the class do not have the keyword static out front. All right. So since this guy is an instance method, or you can think of it as a non-static method, when we go to call get direction, we have to call it using an instance of exit, not the exit class itself. The exit class itself doesn't have individualized knowledge of the direction that an individual exit heads, but an instance of exit. So this dot the exits, which is this room's collection of exits, at bucket I, this guy right here is an actual instance of the exit class. And every instance of the exit class has a direction and it has a destination room. So I'm asking this particular instance of exit to tell us what his direction is. Because in this case, we have 10 different instances of exit, right? And several of them go to the north, several of them go to the south, some of them go to the east and west and things like that. So we need an individual instance of exit in order to get accurate information about where that door leads. Make some sense? That's why we chose to make that method a non-static method, because we want every single copy of exit, every single instance of exit to have their own ability to extract the direction associated with that exit. All right. Super important concept. All right. So inside of our room, we're going to give our high-level information, the name of the room, the description of the room. Then we want to have a line that shows here's the obvious exits with all the directions that lead out of this room. We'll do that by going through our array of exits. How many times? Number of exits, number of times. Each time through, we will get the direction each of our exits leads. Right here, we don't need to know where they lead. We just need to know the direction. Their destination. We can think of our exit here as kind of like a portal, right? When you walk up to it, it teleports you into the, to the instance of room where this guy led, where the room, its destination room. All right. So after I go through that whole for loop, I'll just do a system.out.println. Put the empty string in there. That'll effectively press enter at the very end. So I'll have, north, south, east, west, and then press enter. That would be for the middle room that has exits in all the directions. The first room, it would just have north and then press enter. All right, so we've updated our display methods here for our room. Let's go back to our code here. All right. Now notice here that I don't display my rooms until after I've created my exits and added them to all the rooms. So when I get to this point right here, this line, all my rooms have been filled up with instances of exits. So when I tell them to display themselves, they'll each have the obvious exits that need to come out of this room. So let's look at that and test it. All right. So here, room 1 has an obvious exit to the north. How do we do there? Room 1 has an exit to the north. Room 2, oh, by the way, I didn't put in my my room 6, right? We added the magical room to complete our cross dungeon. All right, so room 1 has an exit to the north. Room 2 has an exit to the south as well as an exit to the north. Goes back to the south, also goes to the north. Room 3 has an exit to the south, the east, the north, and the west. All the directions, which seems to line up to what we have here with room 3. Room 4 is going to have just an exit to the east. Room 4 has an exit to the east. Room 5 has an exit to the west. Room 5, exit to the west. And room 6 has an exit to the south. Exit to the south. All right, makes some sense? All right, so at this point here, we've effectively built our map, right? We've decided on what our dungeon looks like. We decided, here's the names and the descriptions of the room, and we of course spent hours and hours on that. That might be a good use of ChatGPT to give us the name and description of 6 rooms in a dungeon. We should probably give it a certain theme for the dungeon. It would be interesting to see what it went through if we said it's a dungeon shaped like a Christian cross, and see what it names the rooms and gives the descriptions. I'm not sure I want to do that live in class. We don't know what's going to spit out of there, but that might be an exercise I do after class and see what it gives us. All right. Yeah. So we created our blueprint from room. We used that blueprint to create, in this case, 6 instances of room. We created our blueprint of exit. We used that blueprint to, in this case, create 10 individual exits leading in certain directions to certain destinations. We then added those exits to our rooms using the ability we added to our room, the instance method add exit, that allows us to give exits, put exits, install exits into rooms. And then we asked each room to go ahead and display itself, which showed us its name, its description, and then a loop that went through all the exits that are in that particular room. Make some sense? All right, so I think this probably more than solves the homework. You may not have gone into as much detail here, but all right, so questions about this? Go ahead.
Will be a question related to this.
Oh, absolutely. In fact, the whole exam is going to be on this.
Gonna make a question.
Go ahead. You probably, I mean, I don't care. You could write it either one.
About the exam, when is it?
So I don't know when it's right now. Close your books. You got 12 minutes. Go. It actually did happen. One of my faculty in the grad program, some student, I don't know, their Blackboard crashed on them when they were halfway through a quiz or something. So I think there was 4 questions on the quiz. So they gave the student like 1 minute to answer the next question. It just seemed very like weird. Like, okay, you have 1 minute to answer this question. And then the student said, well, that's not enough. Okay, you can have 3. I mean, it's probably legit, but I don't know. Is that really worth the time to like time it on that? So the way I typically will do exams, and I have no reason to think I won't do it this time, is so officially this class has some meeting time during the week for the final exams. I don't know when that is. But so the exam will be on Blackboard. And what I'll do is I will be live on Zoom during the official meeting time. If you want to take the exam in your dorm room or whatever, you don't have to come here. But if you want to take the exam at that official time so that you have access to ask me a question if you want, you can. I'll make myself available. Otherwise, I'll have the exam up probably by Sunday night before finals start, but certainly by early Monday morning. You just have to take it sometime during the week before midnight Friday. You can pick what fits your schedule the best, but I need it by midnight Friday because that weekend sucks. I spend that entire weekend grading. So you get the flexibility of figuring it out how it fits with your other exams, but I do need it in by that Friday, if that's cool. Does that sound reasonable? All right.
And then on it, will we write in C++ and Java?
I probably won't specify. Yeah. Because I mean, hopefully you're seeing that they are extremely similar, right? In fact, realistically, when you think about exams, I don't want you using online GDB or compiler or something like that. So I fully expect your code to have little, bugs in it, right? Maybe you use a dot instead of an arrow or something like that. I grade on competence. So if you show me that, look, I pretty much know what's going on here. And if I were to run this and the compiler screamed at me, I would turn the dot into an arrow and get it to stop screaming at me. I'm not going to knock points off of it for something like that. So I doubt very much I would, in fact, I can't even think of a reason why I would even differentiate any of the questions on C++ or Java. I think the answers are the same on both of them. To that point, that then comes up when I ask a question regarding the idea of pointers in Java versus C++. Probably not. It is an important concept, but hopefully we're seeing here that Java's removed that aspect from us. And we no longer have that asterisk syntax. So we no longer have to differentiate between the dot and the arrow. Not because pointers don't exist, but because just Java said, we'll figure it out, don't worry about it. So I probably would not ask you on the exam that question. It's a concept I expect you to understand and let's say maybe appreciate about Java, that it's taken a couple of those things off your plate for you. But it doesn't really give me a whole lot of information about your current mastery of programming, right? And I don't expect you to be masters of programming yet. This is the end of your first semester of coding, right? So I expect you to still suck, right? But hopefully you're better than you were at the midterm. And hopefully you're way, way, way better than you were day one of class. That's the idea. Make some sense? All right. I probably wouldn't want you to answer questions like with like a Python or something like that. I mean, I can read it, but Python deviates enough from kind of C style coding where, you even this keyword becomes self and that kind of stuff. So I'd probably want you to stay in a C-based language, but if you answered the exam in C, C++, Java, or C#, we're probably fine. Or if you want to do it in some other weird language, I might find that fun. So it's all right. Any other questions? Go ahead.
So will you go over the slides again?
Yeah. So first, probably on that Thursday, was that next Thursday? Is that next Thursday is the week before finals, or we have 2 more weeks? Next week's finals?
Yeah.
Are you kidding me? Really?
Yeah.
Oh my gosh. Yeah, I hate you people. Can't stay around a couple more weeks. I guess on Thursday, we'll be going through the slides and I'll tell you what I think is important. That just knocked me points on the evaluations. Prepared for class. New. Dude didn't know when finals week was. So now I got to write a final exam this weekend. Not on your life. Remember we had that conversation about tenure? Oh, we could do extra credit with quantum stuff. Believe me, the quantum stuff is really fun. I know it was compressed and you didn't have a super strong background going into it, but it is really neat stuff. Okay. Any other questions about this, or I guess upcoming events that are coming quicker than I expected? Okay. So let's expedite a little bit since we need to get somewhere with this. So now we have our dungeon. We have this guy kind of planned out. All right. What would the next step be for this guy? Go ahead. Okay, well, probably at least getting our player in there, right? So we probably want to start off with putting our player maybe into the starting room here, and then having our player be able to go to the north, go back to the south, and back to the north, and to the north, and the east, and the west, and the north, and the south, blah, blah, blah. Have him be able to traverse around our dungeon, right? That'd be pretty cool, so that we can put our player into that world, and we are controlling the player. That makes some sense? All right. So I need to just quickly give you something. Ninja. All right. So I've shown you how to read stuff in from the user in Java. We're saying enter a direction. I'm going to go ahead and type in west, press enter. It read west in, and then this thing was comparing west to east, showing that those are not the same strings. Similarly, if I run this again and I type in east, we get a true because I'm comparing it to east. Okay. So the way we compare strings to each other in Java is using this dot equals method. Technically for this particular thing, you could have used double equal sign, but there's a caveat there why it would work in this case. So let's just say for now, don't. Dot equals is the official way that you would compare two strings for each other. There is also a dot equals ignore case if you want it to be case insensitive. There's also a compare to function that allows you to determine if one string well, actually it's not alphabetically, it's lexigraphically comes before another one, because that would include things like question marks and stuff like that for sorting strings. But for the purposes of this assignment, dot equals lets you compare these things. All right. So let me save this and then share this. homework. Given this dude, add our player to the dungeon and continually ask them what direction they want to go and have them move, and let's say, and allow them to move around our dungeon, showing the current room each time they arrive in a new room. Submit a link to the code and the self-assessment. All right. Questions about that? Should be easy peasy. I promise it's not as hard as maybe your mind is thinking about it right now. All right. You're going to have add the ability for a player to be added to a room. Then have put somewhere the ability to continually ask. The player is our avatar, right? We're telling the player what to do. So if they say, if we're in that first room and they say, where do you want to go? And I type in north, it should detect, oh, you said north. Do I have any exits that lead to the north? Ah, I found one. What do I want to do? I want to remove myself from the current room and I want to put myself into that room. Then show me the new room I'm in. Make some sense? All right. So listen to the last few minutes of the lecture and I just described the way you can go about doing this assignment. Right? If you end up with 300 source code files, you're doing it wrong. In fact, I don't think you need to add any more source code files. You might decide that it makes sense for you if you want to add a whole class for governing this or something, but you wouldn't need to add more than, let's say, one. But I don't think you need to add any. All right. Questions, comments, concerns, bribes. All right. I will see everybody on Thursday, and somebody remind me to go over the test stuff at the beginning of Thursday, because clearly I don't know what's going on in the world around me.
Professor, have a good day.
What's up?
Have a good day, Professor.
You too. You take care.
Oh, really?